Okay, so this is question 2. It says, this question asks you to investigate and prove a geometric property involving the roots of the equation z to the n equals 1, where z is a complex number, for integers n greater or equal to 2. Okay, so I'll just read this out. The roots of the equation z to the n equals 1 are 1 omega, omega squared, omega cubed, omega to the 4, all the way up to omega to the n minus 1. Where omega, by the way, this is an omega, not w. Not that that really matters. Anyway, omega is e to the power of 2 pi I over n. So these are called the roots of unity. I think I even have a video on my in the algebra topic on roots of unity. So it's worth knowing how these roots work. And if you look at them graphically, the roots of the equation z cubed equal 1 look like this. You have a point here and a point here and a point here. The roots actually make a nice equilateral triangle. And this angle here is equal. Now, I actually haven't read the full question here, but it might be something to do with this, and it's worth noting, like, this angle equals this angle equals this angle. And to get from this angle to get from this root to this root, you essentially rotate this line around here 120 degrees, which is kind of where this 2 pi over n comes from. Anyway, I'll get to that at a later point. Let's just focus on what they're asking for part A. So each root can be represented, as we said, P0, P1, P2, P3, P4, P5 on an organ diagram. For example, the roots z squared equals 1 are 1 and omega. So that would just be this, and P0 would be here, and P1 would be here, which would be omega. And the root 1 can be represented by a point P0 and omega by P1. Yeah. Consider the case where n equals 3. The roots of the equation z cubed equal 1 are 1 omega and omega squared. So that's why you've got the omega to the n minus 1, because it starts with 1. And then the second root is omega, the third root is omega squared, etc. Okay, obviously, guys, there's a lot going on there. This is not an easy question. The fact that I have, and generally with these paper 3 questions, I mean, the only way to prepare them is to prepare for them is to prepare all the content. The fact that I've seen and I have some knowledge of roots of unity really helps me with this question, because I feel I've kind of seen a lot of this stuff before. But yeah, it's just a case of the better you know the content, the better you're going to be with these paper 3 questions. Anyway, part 1. It says, show that omega minus 1 times omega squared plus 1 plus omega plus 1 equals this. So this is nothing but algebra. This is just this. Hang on. Omega minus 1 times omega squared plus omega plus 1 equals, I'm just going to multiply it out. This is omega cubed plus omega squared plus omega, that's this times this plus this times this plus this times this, minus omega squared minus omega minus 1 equals omega cubed minus 1 QED. Shown what they wanted me to show. Okay, easy. That question was easy. Second one. Hence, deduce that omega squared plus omega plus 1 equals 0. Right, so he's saying this equals 0. Because if this is 0, it must be a case that this times this equals 0. So I need to first show that omega cubed minus 1 equals 0, and it does. Omega cubed minus 1 equals 0 because omega is a root of z cubed equals 1. So that means omega cubed equals 1. So 1 minus 1 equals 0. So I'm just going to say omega cubed minus 1 equals 0, as omega, let's just say, is a root of z cubed equals 1. So where was I? So this equals 0. Therefore omega minus 1 times omega squared plus omega plus 1 has to equal 0. So this equals 0. And we know that omega is not equal to 1 because the roots are 1 omega and omega squared. So 1 is already one of the roots, so omega is not equal to 1. So as omega is not equal to 1, omega is not equal to 1, omega squared plus omega plus 1 has to equal 0, and that's it. Yeah, you do need to say why this is 0, and you do need to say why this, it has to be this part that's equal to 0 because this can't equal 1. Therefore this bit can't equal 0. Okay, that's part A. Already I often say the part A's are simple, but actually that part 2 was not simple. So this is probably going to be a challenging question, but here we go.